Thank you, Lily. So I'm now beginning to share my screen. Hope you all can see it. Okay. Hello and good morning, everyone. My name is Umair Ali Khan, and my today's topic is AI-driven knowledge access for business. My presentation mostly focus on the opportunities large language models and generative AI offers to businesses. I will start with some basics and discuss how large language models can be integrated to businesses. The major breakthrough in the previous century was when Deep Blue defeated Garry Kasparov. And in the current century, the major breakthrough came when the deep learning started to make stride in image recognition and other tasks. Its variants also made significant progress in natural language processes. And the deep learning continued to evolve and progress, but there were not major progress in natural language processing until in 2017, Google introduced Transformer, another deep learning architecture that was yet another major breakthrough. And it led to the development of large language models. And finally, in 2022, OpenAI launched ChatGPT, which was yet another major breakthrough. And since then, there has been no stopping. But inarguably, the major breakthrough in the last 10 years has been the transformer architecture, transformer with attention mechanism. So let's see how attention mechanism works. Attention mechanism works more or less in the same way as human visual processing system works. While we are reading a text, we do not pay attention to the entire text or in the entire document. We pay attention to only those words which we are currently reading. But we keep track of the context and we are able to answer the questions at any point in time. And this is the same method that the attention mechanism uses. The biggest challenge in natural language processing is understanding the context. For example, in this sentence, we need to understand that the word it basically refers to the animal and not the road. Similarly, in this sentence, we need to understand that the word his basically refers to the customer and not the mechanic. Likewise, in this sentence, we need to understand that the word flies refers to the insects and not the verb fly. It is important to pay attention to important features in the natural language. And this was done quite remarkably by recurrent neural network architecture and its variants like long short-term memory architectures. So for example, in this sentence, RNN are able to understand that bank basically refers to the land near a river and not the financial institution. But while RNN were able to capture good context, they were still unable to understand a long-term context in the natural language. This was done quite remarkably by transformers with self-attention mechanism. And due to the same capability, the large language models can understand natural language so remarkably. So self-attention mechanism basically tries to find the most important tokens or words in input text. It does this by assigning some relative attention weights to each word or token in the input sequence. And with this approach, a model is able to pay more focus on those words which are more important and focus less or little to no attention to those words which are not important. And this goes on and on via a number of layers in large language models, and each layer incorporates its own context to the input text. For example, some layers identify verbs in the input text, and some layers identify the relationship of various words with each other. For example, the topmost layer in this slide identifies his referring to John and the bank referring to a financial institution. So a large language model can have hundreds of such layers. For example, GPT-3 has 96 attention layers. So what is a large language model? A large language model is basically a neural network which is trained on huge amount of data, and it focuses on understanding and generating natural language. And this data can come from books, articles, Wikipedia pages, blogs, and everything that can be crawled from the internet. It requires huge amount of processing resources, training of several days and weeks until we get our trained large language model. So large language model basically is trained using a technique of self-supervised learning, which does not require any labeled data set. For example, for this given piece of text, the large language model masks or hides some of the text in this text, if some of the pieces in this text, and then tries to predict those pieces. And based on the output, the predicted text is compared with the original text to find the extent of accuracy of prediction. And based on this comparison, the large language model adjusts its parameters and tries to improve its prediction for the next inputs. Basically, a large language model is a large word predictor. It basically predicts the next word for a given input text. And it does this by computing a probability distribution of several words from its vocabulary. And it selects the word which has the highest probability in the probability distribution. Like in this case, it will select the word right to be the next word for this sequence. And it keeps doing this until it completes the whole input text. And the same principle is used for other high level applications such as translations, chatting, summarizing, brainstorming, code generation, and others. So while training on huge data set, the large language model doesn't only parrots the training information, it finds the relationship among the concepts. And it is the same capability that allows it to answer questions related to the concepts. So there are a number of large language models available these days, especially after 2022. That is, after the advent of ChatGPT, there has been a surge in large language models, and there are more and more capable large language models being introduced, maybe on daily basis. A few of them, most notable large language models include GPT-4, Gemini Pro, Cloud A3, and open source Mistral. This is the latest comparison of these large language models, both proprietary models as well as open source models. This basically compares their relative performance, and as of today, Cloud A3 from Anthropic has shown to have most superior performance as compared to other models. So the question here is what model to select? It depends on the business need and scope. If you want to go for multimodality, you need to select any of these proprietary models which have more capabilities. And if you want to have more control and want to run these models locally, then you can select open source Mistral, which has shown comparable performance. So why do businesses need LLM integration? Because LLM integration allows knowledge creation, capture, and organization, which is not possible using the traditional knowledge management techniques. It empowers employees for faster access to knowledge. It enhances customer service by analyzing customer feedback, reviews, and requirements. It provides insights to the company for improved decision making. It enables the company to create tailored contents. And it allows more personalization in terms of AI assistants, co-pilots, and others. So how businesses can integrate LLMs into their business? There are several ways to do this, uh, ranging from prompt engineering to pre-training a large language model from scratch. So let us see how each of these methods work. Pre-training is about training a large language model from scratch using a very large data set. and it requires huge number of computing resources, which is beyond the capabilities of most organizations. It uses self-supervised learning, which does not require labeling training data set. And what we get after this training is a generic foundation model, which knows something more or less about everything. But it is not an expert model. It cannot answer questions specific to a specific domain. For that, the companies can fine-tune a foundation model on a specific data set using supervised learning, which requires labeling the data set and using fine-tuning techniques uh, to develop a domain expert large language models, which can be fine-tuned for a number of tasks. For example, customer support, business document analysis, financial assistance, and our onboarding assistance, just to name a few. The other technique that the companies can start with, which is the most simple technique, is prompt engineering. So prompt engineering is all about crafting a right prompt and utilizing the company's data as context with the prompt. So usually this context refers to additional data of the companies, which may include companies' policies, legal documents, marketing strategies, financing, and others. And it can also include examples, instructions, the style and format that we want large language model to produce output in, the role or behavior that we expect from large language model, and the limitations that we may impose on the output. But this context is limited by the context window size of large language model. Most of the current large language models do have a very large context window size, but still the company's data can exceed that context window size. And once it exceeds the context window size, the large language model begins to ignore the excessive context, and it may lead to inaccuracies. A more practical approach is retrieval augmented generation. In this approach, companies' data is stored in a specialized database that is called vector database. So in this database, the data is stored in the form of different chunks or vectors. It's kind of a library in which the similar books are stored together. So the chunks which are semantically similar are stored together. A user's query is compared with this data set, and the top candidate chunks or vectors which have the highest similarity with the query are retrieved from this data set. These chunks are then sent to a large language model, and the large language model then selects the best candidate from these chunks. And based on the prompts, it generates the final output for the user. Advantage of this approach is that it provides updated knowledge because it doesn't depend on the cutoff date of the large language model. It provides personalized access to companies' data, personalized and tailored creation of content, and it is especially suitable for recommendations and matchmaking systems. But it is only able to understand simple queries, and it often fails to understand a deeper context in the queries, and it lacks to understand the semantic relationship between the data items. A more improved approach is to integrate knowledge graphs in the large language models. So a knowledge graph is basically a structured and interconnected view of an organization, which is built on top of existing data sources of an organization. It is basically composed of the entities that could be jobs, roles, departments, companies, and others, and their relationships. A knowledge graph can provide enhanced reasoning, and it is able to understand complex questions and answer those questions which require understanding semantic relationships between the entities or data items. For this sample knowledge graph, it can be interpreted as Bank X operates in Finland, which provides loan to company Y, which is located in Helsinki, and Helsinki is the capital of Finland. So this is how we can encode information in a knowledge graph. While retrieval augment generation architectures are good for recommendation systems, they fail to understand complex queries. This is where the knowledge graph approach could be transformative. A knowledge graph not only performs well for both recommendation and matchmaking system, but it is also able to answer complex queries. And besides recommended a product, for example, it also considers other factors such as the purchase history of customer and the relationship of product with other products and others. The architecture is more or less the same as the retrieval augment generation. It is just that we need some prompt engineering after a user's query to convert the user's query into graph query. This we can do employing, again, generative AI methods. So what advantages this approach provides is that the data can be validated because knowledge graph provides credible and authentic sources of information. It can understand broader context in the queries, and the output can be controlled in the sense that if the output contradicts with the contents of knowledge graph, it can be flagged for reviewing, and just to ensure that the company's decisions are based on accurate knowledge. It also helps in mitigating biases because knowledge graph provides a structured approach of data so that the biases can be detected quite easily. And a knowledge graph is also able to track the relationship and cause and effects of the data items so that it also provides transparency. And since a knowledge graph can learn universally accepted symbols, relationships, and structures, so it is also language independent. So let's consider a scenario here where an employee contacts to a conversational agent based on knowledge graph and asks it for a technical problem. So the user asks the conversational agent this question, and the conversational agent responds. Since it has already received similar complaints, so it knows what the problem is. So it refers to the knowledge graph and finds the relevant links that provide the source of the problem. And then it crafts a response to the user. In response, the user asks another question. So using the similarity of this question and its contact with the previous question, the conversational agent again contacts the knowledge graph and finds the relevant links and provides a relevant answer to the user. So now we will discuss how what could be the possible levels of LLM integration in businesses. So the very first level is the prompt engineering that we already discussed. This is the simplest level of LLM integration that requires crafting an appropriate prompt and utilizing the context of LLM. It seems simple, but it is actually an art, and it is in most cases very effective. So most of the business cases suffice using prompt engineering, and as you can see that a number of applications are possible using just prompt engineering. For example, content generation, email responses, answers to FAQs, content summarization, sentiment analysis of sales, and others. It does not require any technical expertise, and it can be easily kicked off with minimal resources. The other level that the companies can move to is more personalization and adaptation and customization of LLMs. So in this level, the companies can consider about retrieval augment generation architectures, fine-tuning the foundation models on their specific data sets to create domain-specific LLMs. And this can lead to several use cases, for example, AI assistants, co-pilots, recommendation systems, matchmaking platform. And there is also a good possibility of documenting the expert knowledge, that is the knowledge that is in the experts' minds, and then integrating this knowledge into large language models. But this approach or level may require more expertise and resources. In the third level, the companies can move to more adaptation and an advanced LLM integration. On this level, the companies can integrate knowledge graphs into LLMs. And these level also has broader range of use cases, for example, business document analysis, multimodal support, automatic resolution of complaints, customer support, just to name a few. And this is the level where the companies start integrating this new system with their business workflows and existing data sets. On level 4, companies can go for a complete adaptation of LLMs, which is in fact an enterprise-wide integration. This is a comprehensive support to employees and customer, and it provides enhanced reasoning, decision-making, and analytics. A number of use cases are possible, for example, enterprise-wide support, decisions, insights, recommendations, improving customer experience, and even compliance monitoring. An additional feature of this label could be that it will be adaptable to new use cases. So we'll now discuss some of the ethical and technical issues that can emerge as a consequence of LLM adaptation into businesses. Since most of the businesses are relying on these proprietary models, and most of these models lack transparency. They do not reveal their training data, their training mechanism, and other parameters. Data privacy can also be an issue because you don't know how your data will be used for training and fine-tuning these models. Performance degradation of these models is also possible because these models are under constant evolution and under experiments. So at times, their performance can degrade. There are also reports of frequent unavailability and unresponsiveness from these proprietary models, which could be catastrophic in some critical applications. A good option could be to transition to open source LLMs, such as Mistral and others, which are making strides these days, and they are showing comparable performance as the proprietary models. And it is very important to consider the new AI ethics regulations, which will be in place very soon, and it will impose additional conditions on these models and additional rules and regulations. So they will be basically more demanding in terms of transparency. So under these circumstances, the future of these proprietary model could be at stake, especially in Europe. So at the end, I would like to introduce our current project or idea that we are currently working on. So basically, we are aiming to integrate the documented knowledge as well as the tacit knowledge within an organization to develop an AI-driven knowledge creation, capture, organization, and access system using large language models. We consider a wide range of application areas and use cases that range from customer support, sales, service design, business development to skill management and expert search. We are currently inviting solution user companies, that is the companies that will use these solutions into our consortium. Those companies who are interested in this idea can contact us for more details. So this is where I will end my presentation, and thank you very much. I will be happy to answer any questions.
Okay, thank you, Umair. Ali Khan, and we already have one question in the chat, and I will read it, and then you can prepare other questions while we are taking care of the first question. So the first question is about the knowledge graphs. I guess it's about what can they be in practice. So the question is the knowledge graph you mentioned in your presentation the network of documents connected together like a wiki or a corporate wiki? So this is the question.
Yes, it is more or less the same thing. Knowledge graph is basically a graphical data structure. So it can incorporate both structured and unstructured information. So what we do basically is that we identify the entities and their relationship and then encode them in a graphical format. This is what we call as a knowledge graph.
Okay. Hopefully this answered the question of of JCB, and of course you can put questions into the chat also, but now you can also speak up and ask a question if you have one. Okay, now we have in the chat, what kind of partners are you looking for in the project that you are?
So we are basically looking for the partners which are the potential users of our solutions. So they will engage in a co-research process with us, and our use cases will be specifically tailored to their requirements and needs. So we will first understand their requirements, and then we will tailor our use cases according to them. So they will be the main beneficiaries of this project. So they will be the actual user of these solutions. They could be like manufacturing companies, companies related to healthcare and well-being, or companies related to sustainability, software development, and many other domains could be considered.
Okay. Thank you. Okay, then, well, I have questions, but if someone from the audience, okay, great. Which LLMs allow you to integrate knowledge graphs? There's a question.
Well, it is not about any specific LLMs. So there are two approaches of integrating LLMs to integrating knowledge graphs to LLM. One is more or less the same as we discussed, like a RAG architecture. So you can integrate an LLM, a knowledge graph into LLM using a RAG architecture, where you use knowledge graph instead of a vector data set. So you first retrieve information from the knowledge graph and then send it to the LLM for generating the final output. The other method could be to fine tune an LLM on the knowledge graph. So that's another approach. And then we can evaluate which one of these perform better. RAG approach is more practical because it allows you to update knowledge graph frequently without retraining the large language model. Whereas if you go for fine-tuning approach, you need to fine-tune the large language model every time you make some updation in the knowledge graphs. Okay, so there is another question, like interesting KM project. I wonder what type of tacit knowledge will be captured and how. In some cases, tacit knowledge includes some legal information, some policies that are not well documented, but they are in the heads of some people. And every time, based on the needs, we have to refer to those experts. For example, for for creating some draft or taking some other decisions. It is possible to document this knowledge. For example, in the form of 30, 40, 50, 100 pages, 200 pages, and then we can develop a RAG architecture, potentially using a knowledge graph where we integrate this documented knowledge into the LLM. So instead of referring to these experts, we will be referring to this LLM system for our desired output.
Okay, thank you for the many answers and also for the many very good questions. So, well, I ask one question before we move on. As I showed in the introductory slides, one big obstacle of not taking LLMs into use in businesses was the accuracy, so that businesses feel that they cannot trust the results of the generative AI. We all know that they do hallucinate, and we also know that typically in the vanilla versions do not provide the sources or any explanation on how they came up with these answers or information. So I was wondering if the RAGs models could be one solution to increase the accuracy of the models, so that you can, for example, put your own company data in there and maybe also show some sources to the user. Where does this answer come from?
Yes, this is possible. And this is the very purpose of a RAG architecture. So RAG architecture mitigates hallucination to a greater extent, although it does not completely remove it. There is some possibility of hallucination, but it is greatly minimized. And also it can provide citations for the output, like it can tell you which document or piece of information it referred to generate the final output. So this is the major advantage of using RAG architecture. Not only it provides you your company specific information, but it also prevents hallucination, which is an inherent limitation of large language models. And then this problem can be further mitigated by using these knowledge graph approach. Like I said, that they will provide further credible sources of information. So you can check where this information is coming from. You can even check what is the rationale of a cause and effect, because it can track all the links and representation of data items, and it can provide you the reasons of a certain phenomena, or the reasons of a certain event. So this is why knowledge graphs are so useful.
Okay, thank you. So I guess this is very useful information for businesses who need systems where they can actually trust the answers generated by the generative AI. Okay, but so thank you very much, Senior Researcher Umair Khan, and